start with a question. How many of you like to be in control, or maybe a better question, do you like to be in control or do you like to be in chaos? Control or chaos? Control. Everybody in control. Wow. Okay. So I'm not going to exert my opinion on what's bad or what's good about this, but I would say that I don't think it's like a binary choice, right? It's always a spectrum, right? And that's where I want to use this spectrum to disambiguate how should product teams, right? When I say a product team, I mean like a cross-functional product team, which includes your quality analyst, which includes your developers, all the roles that we talk about. How should product teams understand and look at software quality as a paradigm, right? So I'm going to use this spectrum because I don't think it's a binary state. At one moment, you are probably in control and the other you fall into chaos and, vice versa. So it's a spectrum. Anyways, before going into, you know, what are the new age systems that we all of us are building, probably powered by I think it's really important to, deep dive into the past because in my opinion, the future is a glimpse or reflection of what happened in the past, right? There are tons and tons of learnings of how things evolved, what seismic shifts actually happened and how we progressed when it comes to technology. All right. Let's take you down the memory, the nostalgia of the last 25 years of doing software development. Agile methods. Remember 2001? I think that's when like a significant shift from waterfall to building software in an agile method where customer feedback, right? Regular customer feedback became really important, right? And what it meant was that testing was not a phase anymore. It sort of moved into the development process, right? Because you wanted to gather customer feedback much more closely, right? That's Agile Methods 2001. By the way, the Agile Manifesto, our chief scientist, Martin Fowler, I'm sure all of you know him, was the signatory on this manifesto at that time, right? So that's when it started. CI/CD 2009, right? Anybody knows cruise control? Have heard the name cruise control or Go CD? Go CD? Yes. So cruise control was born at ThoughtWorks in 2001, right? So, but pretty much in 2009, when Jez Humble and Dave Farley released their book on continuous integration and continuous delivery, is when CI/CD actually came to the fore, right? And pay attention to the part of testing here, right? Automated testing tools like Selenium. Anybody know Selenium here? Please raise more hands. Thank you. Right? 2004 is when Selenium is born at ThoughtWorks again. And by 2009, we started to see how automated testing, right, moved into your CI/CD pipelines, right? We could get a lot more continuous feedback as we are developing the software, right? So you see the shift from testing moving closer to testing actually getting embedded in your CI/CD. Then comes DevOps, right? Close to the heels of CI/CD came the aspect of moving or sort of unification of the ops world with the development world, right? Like shift left was the main theme, right? The idea was to look at software quality as a team sport, right? It did not remain like a QA team sport. It became like a team sport for the cross-functional team, which is actually developing the end features, right? So that's when 2010, when collaboration, shared responsibility started to become of real prime importance. Then comes microservices, 2013, right? From service-oriented architecture to more scalable, independently deployable units, microservices, right? And again, from a testing perspective, what happened? The shift from testing a monolithic service-oriented application to independently deployable, scalable units. You see the challenge? It was, of course, a huge shift because they are not now at one place. They are across distributed servers, across different regions, across different geographies, right? So there was again a shift that happened when it came from Microsoft services. Then comes testing in production. Again, this is more from shift right testing, right? I think I mentioned this in one of my last talks as well yesterday that you cannot possibly test all the permutations and combinations of the software in a distributed ecosystem. Can you? Like, can you make sure that you're verifying each and every line of code with the test harness that you're putting up? It's impossible, right? And that's where testing in production began to shine, right? Observability began to shine, that you would observe your systems, you would monitor your systems to make sure that everything is sane and working fine in the production environment, right? And more critical, real-time user feedback became more important to look at whether my system is in a good shape or not, because it's pretty much hard to, navigate all the possible pathways in your application. And then what happened? Guess what? AI. ChatGPT 2019, right? AI commoditized. So, and then I like to use this phrase that AI was in the background up until then, right? It's not that AI is new, but AI was in the background. What happened with this is AI came to the foreground and it became a commodity, right? We sort of lowered the barrier for everybody to use AI in very different ways. And now we see that, sort of run towards building AI powered apps. Rightly so, right? And my hypothesis is, looking at this trajectory that in the future, all software that we see is going to be AI ML enabled. How many of you agree with me or disagree with me? Okay, a lot of agreements. That's good. Yeah, that's my hypothesis that, because it's not going to take 100 times more money to build an AI ML powered application, but it's going to be 100 times more competitive than any traditional application. Right? That's the hypothesis that I'm taking, that in the future we are going to be building more and more AI enabled applications. With that, right? Like if that's the hypothesis, if we are going to build more AI powered products, how should we think about testing strategies? How should we think about software quality in this new world, right? And that's where I said at the beginning that I'm going to use a spectrum from control to chaos to paint that picture, to give you a mental model where you can fit how to think about testing strategies for such systems. That's where I want to introduce a very interesting framework called the Canadian framework. How many of you have heard of this framework? Show of hands. Okay, not many. Great. I like this. This gives me the opportunity to actually explain it in, a little bit more detail. By the way, this framework is not new. It was created by Dave Snowden from IBM in the year 1999. So it's really, really dated. But what I have done is I have used this framework, which was used for organizational decision making, to bring it to the software development. Well, I'm going to give you, my hypothesis about how I did that mapping, right? So that's the Canadian framework. It has 4 domains, as you can see, right? And they're not clearly demarcated domains, as you can see with the swirl lines here, right? They are like fuzzy. There is a lot of fuzziness that's going on. And the center domain is like, we'll come to it at the end, but there are 4 broad domains. The domains on the right are ordered domains. What do I mean by ordered domains? It means that the cause and effect are connected, right? You can easily come down to what's the effect of this cause, right? So cause and effect are very much related. But in these two sides, right, on the right hand side of me, or the whatever this is for you, these are disordered domains, right? The cause and effect are not evident, right? You cannot make a connection between why this happened, what happened immediately, right? So you need a lot more. So that's the high level. But let's get into each and every domain very specifically. The first domain is called the clear domain, right? This is a domain where, as I said, the cause and effect are very tightly related, right? If you do X, you get Y, right? So this domain operates with fixed constraints. Imagine building a loan processing system, like a rule based loan processing system, which has very specific rules that a loan should fail, the application should fail, if the monthly payment of a loan installment is greater than 35% of the gross income of the person. A very simple rule. If that rule fails, it's a fixed constraint, and you know that the loan will actually fail, right? So what you can do in that domain is operate from best practices. Proven things, proven techniques are going to work really, really well in this kind of domain. Now, draw an analogy to the software development world. Imagine building a simple CRUD app, right? Like there is a basic simple CRUD app with a basic screen. Imagine the login functionality. You enter the right password, you enter the right credentials. What's going to happen? You are going to be logged in to the system, right? It's a very simple application. It probably belongs to the clear domain, right? What do you do here? You first sense what's happening, you categorize, and then you respond, right? There is no expertise required because you're operating from a very fixed set of constraints in the system, right? It's a simple app, and you know that if you do X, you will get Y, right? So it's very deterministic in nature, right? So we can also say that you're operating from standards, or in a more common term, it's the domain of known knowns, right? That I'm sure that term is more familiar than the rest of them, right? It's the domain of known knowns, right? You know what's happening, have a direct control of if you do X, Y is going to happen, right? Let's take a shift up. Complicated domain, right? In the complicated domain, there are governing constraints. What do we mean by governing constraints? That there are certain rules, but that it's not directly visible that what's the relationship between cause and effect. You would need some sort of good operating model, some sort of good practices, and the need of experts, right? What do we do? We do sense. What do you do? Analysis, right? You see the difference between sense, categorize, and respond. Categorization is imagine a pipeline of incoming. This goes X, this goes Y, right? If it's meat, it goes on the left belt. If it's vegetable, it goes on the right belt, right? It's very manual. You just have to sense, categorize, and respond. But in the complicated domain, you need some expertise. Now, you need experts. Now, let's take an example from the software ecosystem, right? Imagine a simple service-oriented architecture-based application like a monolithic system. All of us understand as techies that it's important to monitor the CPU usage and the memory usage, right? Make sense? We monitor that. Now, sometimes the application under peak load, it works fine, and sometimes it does not. You know that the CPU is spiking, you know that the memory is spiking, you know from your expertise that something is going wrong, but you don't know what's going wrong. So what do? You call in an expert. All of us here are experts, right? We call ourselves in and we analyze. Hey, what's happening? Like I dig a little deeper, but it's again known unknowns, right? We know what's happening, right? But we still don't understand it yet, right? But you see the cause and effect are still related. You can get to the uh, cause looking and doing an analysis as an expert, right? You understand that? So it's very important to hold this model in your head because we're going to keep coming back to it, right? So do what you have to, take pictures or whatever, but keep this in your head, right? That's the complicated domain. Now comes the complex domain. Now, this is an interesting domain because in the complex domain, you do not have a direct relationship between cause and effect, right? You just cannot make sure that, hey, why this happened? What happened? And there is no correlation whatsoever. Why? Because there are enabling constraints, right? The ecosystem is acceptive. You did not, acceptive as a word means that you did not even imagine that your system is going to be used in some way, but it's getting used in that way, right? So it's a complex system. What do you do here? You probe, you sense and respond. Now, bring it back to the microservices world. What do you do in microservices? When you have a production issue, what do you do? Anybody? What do you do? Logs, right? What's that called? It's probing, isn't it? You probe into your system. You probe into what your system is saying internally, right? It's like looking into the gut of the system by looking at the logs or the monitors or whatever that you have set up in your observability stack. And then you sense what's happening and then you respond, isn't it? You don't fix a bug directly going into the code. You look at the logs, you probe what's happening, right? So this is the place where you do experiments. This is the place where you build hypotheses because you don't know what's going on. It's a complex system. It's the domain of what? Unknown unknowns, right? You don't know what's happening. So far with me, makes sense? The model is sitting well in the head. All right. So I would say that microservices kind of systems, distributed systems will all sit in the complex domain, right? Then comes what? Chaotic. My favorite, chaotic domain. What do you think happens here? No effective constraint. There is just about nothing that's. Are you able to see the slides from here? Okay. Why don't you come and sit here? Right? So, chaotic, there are no constraints whatsoever, right? Your application is out there in the wild. Anyone remembers Tay, the bot, the Twitter bot from Microsoft? What happened? Twitter got the best of Tay, right? It learned interesting racist and sexist and narcissist comment, and then it started spewing that language. What did Microsoft have to do? Shut it down, right? That's exactly what happened, right? This is a novel domain. What do? You act first. At that point of time, the only recourse that Microsoft had was to act and take that thing down for doing anything else, right? So, in this domain, the systems that belong in this domain, you act first, you then sense what happened, and then you respond, right? So that's a like very interesting way to understand the complexity. And this is like a random domain, and it's unknowable. I don't know if you can see it from here, but it's unknowable, right? You cannot even know what's happening. And I would say that all these new AI-powered systems, agentic systems are all going to sit, somewhere at the cusp of these two domains, right? Make sense? Excellent. But what's the general idea of testing today? What's our idea of testing? Hey, it's going to be more questions, huh? You have to stay awake after lunch. I understand, but you have to stay awake. What's the general idea of testing? Sorry? Huh? Okay. You expect something, right? You expect a future. Basically, today's traditional testing mindset says that you are going to predict what's going to happen and you predict and you expect that future to happen. Correct? But in case of non-deterministic systems, the kind that we are going to build in the future or we are actually building, can you do that? Probably not, right? And that's where I introduce another framework called the vector theory of change, right? I really like using these frameworks because it gives you a mental model to think about something and disambiguate a problem and break it down and wrap your head around it because that allows you to take better decisions, right? So this sits very well and complementary to your Canadian framework. They both allow you to take certain decisions, okay? Now, the vector theory of change says, and everybody understands vector. I'm sure you have read physics and maths, so you're all nodding here. Excellent. A vector has a magnitude and it has a direction, correct? Now, what do I mean by that? There are no specific end goals. It's just a direction, right? And when you apply vector theory to anything that you want to do as a decision making organization, you set a direction. You're not saying that this is the endpoint that I want to reach. You set a direction and you set a high level goal and then you try to align all your efforts towards that, right? So what needs to happen is that all the vectors, they don't have to cut each other. You know, right, that vectors in opposite direction, they cancel each other. So all the vectors have to align in the right direction with the right magnitude so that we can achieve a goal that we are trying to work towards and directionally make progress, right? Now, an example here is if you want to build a responsible, trustworthy AI system, that's your goal. That's your direction that you want to take. All the vectors have to align in that direction. Like think of the possible vectors here, right? Your testing strategy. What sort of tests should I write for my model layer? What sort of test should I write for my data layer, right? What sort of test should I write end to end? What sort of test should I write for my retriever if I'm using a RAG-based system? You get the point that all your vectors should align in the direction of your goal, which is building responsible and trustworthy AI system. So far, Bimbi, make sense? All the frameworks with you? Excellent. And for that, let's look at what are the certain characteristics. So we are going to take an example in this talk, right? So that you can, map whatever frameworks that we have discussed and mental models that we have discussed to a actual AI powered system as an application. Okay, so we're going to take an example. But before that, let's look at what are the characteristics of such AI systems. First one, not a surprise, stochastic, right? They can have many correct and incorrect outputs, right? Make sense? Subtle incoherence and hallucinations. If you were in the panel yesterday, we spoke about hallucinations a lot, right? Of course, your AI systems can hallucinate because owing to its stochastic nature, right? It's not magic. I'm sure all of you are techies, so you understand that based on whatever learning data your LLMs or your models have seen, they're just calculating probability of what's the most likely next token that I should emit out, right? So it's a probability game. It's stochastic. So no wonder it can hallucinate. No wonder, given a question, given a query, it can give incoherent answer because it doesn't know what's right and wrong, right? It's just trying to guess the most likable answer that you can like, all right? Then complex LLM chains. I can tell you for a fact that when we are building complex AI systems, it's not one model that we are talking about. Possible? Only one model in the architecture? No. It's going to be an ensemble of models, right? That means there are multiple models that are taking part in that system, right? So it's going to be complex LLM chains. And when there are multiple LLM chains coming together, it makes or extrapolates the problem to another level because now you're not just talking about one model, but multiple models coordinating, exchanging information. That's pretty much the premise of your agents as well today, right? You do handoffs or you're collaborating and communicating, right? So we are talking about complex LLM chains here. Evolving evaluation tenets, right? Can I possibly build an AI system today and say, it's toxicity free, it's bias free, it's accurate, it's relevant? Is it? What is happening? It's evolving, isn't it? What's bias free today is probably is biased in the future, isn't it? So it's evolving. So you cannot at any point of time just step back and say, now my system is ready and just rest up and say, it's all good. No, it's not. Because these tenets are evolving. You have to keep coming back to them over and over again, right? Evaluation requires for both. This is the first step. This is very unique, right? If your input changes, your output, of course, changes. So you have to evaluate both the things. You remember we spoke about guardrails yesterday in the panel. If the input is bad, you might want to, just kill it right there, right? So you have to evaluate both input and output, not just the output. So the traditional testing, I think all of these characteristics just shatter those notions right away. Make sense? Last but not the least, sensitive information disclosure. Just nudge the AI without guardrails to give you sensitive information. It's going to give you that, right? So a lot of times this happens that the AI unknowingly, innocently gives out sensitive information without even it knowing that it has done that, right? So if there are no proper guardrails and, constraints in your system, and all of this should map back to your, the Canadian model that we spoke about, that this kind of a system which is so non-deterministic, which has so many evolving aspects, which needs information, which needs guardrails at multiple levels, is sitting in the complex and chaotic domain, right? And you cannot think about it in the same way that you think about other traditional systems, right? This just to take some examples. Is Kerala a good place to vacation? Even that's the right answer. Even this is the right answer. I don't know if you can see this. Maybe I should just on this side, right? I hope you can see both correct answers for same input, right? When if you look at this, it's the same essay, but one time the score is 7 and the other time the score is 4. Nothing changed, right? So same input, multiple outputs. Another interesting thing, right? I was speaking about hallucination and incoherence. Look at this. It's the IPCC report. By the way, these screenshots are from a tool called Giskard, Giskard. It's a fantastic tool for doing these kind of tests on your AI powered systems or your models that you're building, if at all you are. So this is about this IPCC report. This is our test document that we are using, and in one of the questions it says, why does the IPCC report predicts that there is going to be loss of biodiversity in the name of climate change? And that's the question, it gives the right answer. But as soon as you tweak the input a little, you look at input 2, why does the IPCC report suggest that there will be an increase in biodiversity due to climate change? Look at the response that it gave. It said, yes, there will be increase in biodiversity. You see what I'm trying to say? That your AI, when nudged in certain ways, in different input conditions, it can hallucinate, it can give you incoherent answers, right? Just a small change in the input prompt. And that brings me to the question, do you think benchmarks alone are enough to look at it? What are benchmarks? Benchmarks are nothing but what model creators release when they release a model, right? It's sort of a leaderboard, right? That what's against a given benchmark, what's the performance against certain other state of the art models that I have, right? I would say that take benchmarks with a huge grain of salt, because you don't know whether that specific model has actually seen that benchmark questionnaire itself, right? So it's already trained on it, so it knows the answer. So it can just completely game that benchmark and go right up into the leaderboard, right? And that brings us to the point that for your specific use case, when you are building an AI system, you need an evals strategy. Anybody heard of evals so far? Evals? Okay. Yes or no? Yes, evals, right? Now, why are evals important? Because they are specific to your use case, right? How you want to use the system, what are the target users that you want to target, and what's the specific problem that you are trying to solve, right? So, your evals are within the boundary of what's the application area of your AI powered system. So you cannot rely only on benchmarks. You have to have a solid evaluation strategy for your AI systems, which we're going to cover in more detail as we take the example. Now, this is a simple diagram for a typical RAG system. Everybody aware of RAG here? Retriever augmented generation. If not, let's take a small example here, right? You have an LLM, you have a set of documents, given a user query, your system, your retrieval backend, looks at your document corpus and extracts the right relevant documents that aligns with that user query, right? And then it puts the context of those documents into the context, which then goes into the LLM, right? So what has happened is you have refined or added enough contextual information to your user query, which was the first step by fetching relevant documents from your document corpus, right? So you're grounding your prompt in your document corpus. So that's the basic setup of RAG-based system. There is a retrieval component, there is a generation component, right? Retrieval is the part which is doing the heavy lifting of getting the right chunks, vector chunks. Can you please close the door? Yeah, right vector chunks from your vector database and adding them to the user query and getting then the generation part takes that context and generates the right response based on that context. Right? This is a RAG system. Now, if we look at it from a metrics perspective, there is a question, there is a context, and then there is an answer, right? What are the metrics that are involved typically in a RAG-based system? Context recall and context precision. What it really means is what's the value of the recall that you could do by fetching the right or retrieving the right documents from your corpus, right? So recall is about how effective is your retriever in identifying what is that information that I should fetch from my document corpus to be added to the context, right? So that's the part of context recall. How effective am I to recall the right documents during the query? Make sense? Then comes context precision, right? Now, precision is measured at, say, top K. If I'm fetching top K results, how many of those top K vectors or documents that I fetched are actually aligned to this user query, right? So that's the metric of how good is your retrieval, the R in the RAG, right? How good is your retrieval, because that's going to set the tone of how generation is going to look like, right? Because context is king or queen, whatever you want to call it, right? So these are the two metrics for your context from the retriever side of the things. Then comes relevance. As you take that good context, you embed that in your prompt, you ask that question to your LLM, what's the relevance of the answer, right? Is it solving the problem or the user query that was originally asked? Or is it relevant? Is it coherent to what was the context and what was the user query? Is it solving the problem? Is it giving the right answer, basically, right? By the way, there is no right or wrong answer. Is it coherent? I think that's where we are using the word. Is it coherent enough and relevant enough for the problem at hand? We are not using the term, is it right or wrong? It's whether it's coherent. I think there's a subtle difference here. So I hope you understand this, right? So we are talking about relevance here. And then the groundedness, right? How grounded is this specific response in the data that we have set it up against? Make sense? These are the broad metrics. I'm not saying that these are the only metrics, but these are the broad metrics to give you, a simple mental model of how to think about evaluation of a RAG-based system. Now let's look at this, right? You see that cute little box there in black? That's your LLM. It's a black box, right? It's a black box. LLMs are black box. I love this term, right? It's a black box. The model parameters are tuned, but the surrounding parameters are not, right? When this is a RAG, by the way, this is just a flattened view of that diagram. Don't get confused. It's not a new system. It's the same flattened view of the previous diagram. There is data. You parse that data. You vectorize that data. You ingest that data into a vector database. You create that index, and then you retrieve. You give the context to the LLM, and then you create the response. Jerry Liu, the credit of this slide is to Jerry Liu. He's the founder of Llama Index, a popular framework for building, AI-based applications. Now, interesting thing is this: when one part of your pipeline is a black box, what happens? Previous parts also become black boxes, right? So that's the challenge with AI systems, right? They are extremely complex. They're extremely chaotic because There are so many parameters here. I'm going to give you the parameter list here, right? What all is happening in this nice little simple diagram of yours, right? What's happening? The first one, chunking strategy. Anybody understand system? What's the chunking strategy? The way you have broken down your document corpus. I think you were asking that question yesterday, right? So that's the first thing to think about. This is going to be part of your evaluation strategy. This is going to be a part of your one of the vectors that you have to keep monitoring when you are evaluating and testing your AI RAG-based system. Chunking strategy means how you have chunked your document corpus. If it's a large file, say of 100, 2,000, 3,000 pages, just making it up, how have you chunked it? What's the unit of a vector in your DB, right? Imagine a simple Q&A application which is supposed to give very small factual answers, like short factual answers. If if the recall is poor, you might have to reduce your chunk size. You get the point? Because it's losing that context because it has to give a very short response. So if you give it more context, it's going to get confused, right? It's called the lost in the middle problem. More context doesn't mean more better answer. It could mean even a bad answer because it can get confused in too much context, right? So you might have to relook and revisit your chunking strategy if that's your AI system that you're building, right? Choice of the generative model, right? Given the same prompt, do you think same prompt will perform excellent in all types of models? No? Yes? No? Maybe? No. Good. Why? Because every model has its own context, right? Your choice of generative model is going to define how your AI system is gonna behave, right? A single prompt which you have tuned very well for one model might fail spectacularly with another model, right? So there is no fixed. So what is the other vector we have to think about? Your prompt, your system prompts that you have embedded in your RAG based system, right? So we have to think about the right model because the model and the prompt have to go hand in hand. There is no guarantee that one prompt that works well with one model is going to really fly good with the other models as well. Choice of embedding model. What's the embedding model? The model that's used for creating those vectors from your documents, right? So if you're taking your documents, you're vectorizing them, you will have to use an embedding model to create those embeddings, right? Those vectors. Now, what embedding model do you use? And why I say that is because if you are building a very domain specific application, imagine, a healthcare application or a financial application, AI system for that matter, there are certain jargons, there are certain nuances of that specific domain that all of these large models might not understand. And therefore, if you're using a generic embedding model, you might lose some of those nuances in your capturing those nuances in your vectors when you do the embedding, right? And therefore, what embedding model you're using, are you fine-tuning your embedding model becomes another, vector in your mental model of how are you thinking about building your AI system, testing your AI system, evaluating your test AI system, right? Retrieval mechanisms, right? There are several types of retrieval. I'm sure all of us already know text-based, keyword-based search, right? Like all of us understand that. Now, should I use text-based search? Should I use vector-based search, which is a semantic search? Should I use a hybrid search? Should I use combination of both, right? So your retrieval strategy is going to have a huge impact on what's your context recall and context precision. Are you able to relate to it? Are you going to use a text-based search? Are you going to use a vector-based search? Or are you going to use a combination of both of these? That's going to have an impact on how good is your context precision, how good is your context recall, because these are your retrieval metrics. You remember from the previous slide. And choice of hardware infrastructure. If you're hosting the model yourself in on-prem, right, even that's going to have a huge difference on what's the performance of your system, what's the latency, right? Because at inference time, if the infrastructure is not proper, you're going to have a lot of latency. Your request might time out, right? So that again becomes another aspect of how good is your infrastructure. Are you hosting it in the cloud? Are you hosting it on-prem or your laptop, right? If you're building personal assistants for your own consumption, right? Like my M1 can easily run a 13 billion parameter model with Olama. Everybody aware of Olama? It's like a Docker container for your running your models locally. With M4, you can run 3 or 4 of them. So that's great. Apple Silicon is making progress. I'm happy. The question again, do you think for such a system, the one that we just spoke about, the RAG-based system, what sort of testing is required? Isolation or end-to-end? Isolation, raise of hands. Isolated means like, all the different components. Sorry, somebody said both. Thank you. You need both. Excellent. You need both, right? You cannot just say that I'm going to only do testing in isolation or I'm going to only do testing in end-to-end fashion. You have to do both of them, right? Let's look at the example of isolation. Now that's your retrieval, right? You have to test this retrieval component in isolation. What does it look like? What do we do? Come on. We have to evaluate the quality of retrieved chunks given a user query. Right? That's the R of your RAG. You have to test in isolation how good is your retrieval mechanism given a user query. What do you do for that? You create a test data set, right? Please pay attention to this, but you create a test data set which has the query, like sample user queries, and the ground truth documents. Given a document corpus, you know that given a certain kind of query, I mean, I'm sure if you're building a domain-specific AI system, you will have SMEs and domain experts working with you. So you sit with them, you make a test data set which has, a good set of query and what's a good ground truth document that must be retrieved for that query, right? And you have like a big data set of that, which is your test data set. And then you measure the retrieval metrics, right? The context recall and precision. And the specific thing that I'm talking about is MRR, mean reciprocal rank. That means what's the rank of the first document that has been fetched in the document corpus, right? Is it rank 1 or not, right? Because the first document is the most critical document, right? So you measure MRR, you measure precision at K, which is also what context precision about, the top K. In the top K documents that you have fetched, what's the precision of how many documents actually align and relate to your query that you are looking at, right? So that's what you measure in isolation for your retrieval component. What does the end-to-end look like, right? You have a user query, you have your entire RAG pipeline, and you get a generated response. How do you do that? You have to evaluate the final generated response for your RAG-based system. Now we are talking about the end-to-end test. What's the test data set here look like? It looks like for a query, what's a good relevant answer? You see the difference? In the first one, where we were only testing the retrieval, we were looking at, given a query, what are the good set of chunks and documents that should have been fetched from the DB? In here, when we are talking about end-to-end, we are talking about, given a query, what should be a good, coherent answer? All right? There are, and that you're going to have many, many of them because that's what, you cannot have just one. You have to have many of them because you know that it's language that we're talking about. And then we will measure. What are you going to measure on the final generated answer? We're going to measure the faithfulness of the answer, relevancy, adherence, toxicity. These are just a few that I'm mentioning, but I'm sure there are going to be more given your use case, given your context, given what problem you're trying to solve. All right. Now, this is how it's going to look like, right? With automation in place, with all of these tests, as you make a change in your AI-based system, your pre-commit evals should run. Pre-commit think of evals like tests. Okay, based on your evaluation strategy, you are going to build the tests using the test data set that we spoke about. You're going to, pre-commit evals. Before the commit, eval is going to run. You deploy to staging. Before a release or before a deploy to production, your pre-release evals will run. And the shape and form of them can be similar or could be different, right? And then and then there are continuous evals. You see this part? You remember when I spoke about how toxicity, bias are evolutionary tenets. So that feedback loop has to be there, right? You have to have continuous evals in your system to give that feedback. So there is a feedback loop from every step. You see this? Right? So that's how your automated path to production for an AI system can potentially look like. Is that enough? Is that enough? Is automated only enough? That's the question. Right. Both. So you need both, right? You cannot only trust your automation. You have to have the human in the loop, we in the loop, right? Human evaluation is equally important. Anybody knows what's the term for that? Huh? Uh, something better, something more trendy. Oh, that's too much. Vibe checking. Anyone heard of vibe coding? You have heard of vibe coding? Yes. That's vibe checking, right? Like, hey, what's the vibe of your system? Right? Like, just imagine you plug in your headphones. You are the subject matter expert. You are looking at your system and looking at how it's executing its your test data set and say, hey, this looks good so far. That's vibe checking, right? So you need that as well. As a human expert, you have to be in the loop. You have to look at how your system is performing and giving you what sort of vibe is it giving you, right? So I think that's a very important element. Maybe you can call it manual testing also, but I'm going to give it a cool name, vibe checking. Yeah. Oh, suspense pick. Sorry. Another question. Is that enough? You already saw the answer. I'm so sorry. Well, is that enough? Like automated testing in your pipeline, um, human in the loop with vibe checking. Is that enough? What's missing? Damn it. Observability, right? Like, this is my favorite. Actually, while building AI systems, one thing that I did not say in the panel, if you really want to make your AI system spectacularly fail, forget about observability, right? You cannot build a production grade AI system without this in place. And why do I say that? Because you need continuous evaluation. I think I mentioned this to this gentleman yesterday that you have to monitor the live production usage of your AI system. How are your users using your AI chatbot or AI system? What sort of queries are they putting in? How are they interacting with it? And what sort of response is your system generating? You have to continuously evaluate that, right? You have to monitor for what's the latency of your AI system, right? What's the time that it takes to respond to that query? What's the token usage? Very, very important, right? You're burning money. Now we are talking about token economics, right? Every token counts. So what's the token usage? How can you optimize your prompts? Because it's going to burn money. The cost, performance, bias, relevance, and dot, dot, dot. Many, many more. The ones that we spoke about, all of them in good, nicely projected in your observability dashboards, right? There are tons and tons of tools in this space. I can name a few for you. Langfuse, Langfuse or SE, I don't FUSE, I think, Langfuse. It's a fantastic observability tool for your AI systems. It's open source, but they also have a managed offering. I'm not a representative of them, but I'm talking about this based on actual usage at ThoughtWorks you know, in client projects where we are actually building such systems. So Langfuse is great. Langsmith is great, another option, from the LangChain folks. Many, many more. Helicon, you just go to the tech radar report and type for tell me in the last radar what were the LLM observability tools. You'll get a list of them because they're all pretty much Datadog, by the way. I'm sure you know Datadog. They have really upped their game when it comes to LLM observability and all of those things. So even Datadog, if you're already using that, why not? Right? Tracing LLM chains, right? Imagine you remember I spoke about how an AI system is made up of multiple LLMs, right? There are complex chains in that ecosystem. And how do you trace the request and response? You remember tracing? Like observability also talks about tracing in the traditional sense, right? So tracing of request response, request response, request response, if there are complex chains in your AI system, right? So observability tools or observability as a concept should allow you to do that. You should be able to look into each and every sub step to verify whether this worked end to end fine or not, right? So that's the tracing part. Data flywheel, that's the most important thing. You remember we spoke about the test data set, right? Test data set. Do you think that's static? Yes or no? No. Why? It's changing, right? Your users are using your system in new ways. You remember the Canadian model of complex acceptive? You don't know how your users are using your AI system, do you? You don't. It's language based. We as human beings have the leverage to do anything with when it comes to language, right? It's acceptive. It's a complex system, right? So it can be used in ways that you have not even designed it for, right? So you have to create a data flywheel. And what I mean by that is when you're monitoring your user queries in your production system with the help of an observability system like a Langfuse or a Langsmith or whatever that you're using, you are continuously updating your test data set. That's a very important point. Please note it down if you're making notes. That's a very important thing. You are continuously updating your test data set with, with the help of the actual live data that's coming in your system, so that when you run your evals at all the stages that we saw earlier, you know that your system is actually reflecting the current snapshot of how your technology is being used by the customers. Yeah, does that make sense? Okay. Evolutionary metrics, of course, you need to be able to, look at how your metrics are evolving over a period of time, because as a designer of an AI system, you will take several decisions. Should I upgrade my model? Should I change my embedding model? Should I change my chunking strategy? So you need to have very good handle on how your metrics are getting impacted with every change that you make in your design. Now that's how your your flywheel is going to look like, right? Now, what we have added is we have added observability right at the bottom, right? We have added that lady and that gentleman right at the top doing vibe checking on your system, right? So this is how your complete system is gonna look like. Your path to production with a human in the loop, with the right observability and with the right ecosystem and systems put in place to make sure that we are doing the right thing, right? That we hope that we are doing the right thing. We don't know we are doing the right thing. All right. By the way, there's that's not part of the slide, but I think I should mention this. One of a good strategy of evaluating your LLM-based systems is also called as LLMS judge. Anybody heard of this? Like you use a more powerful LLM to evaluate the response generated by your application. Like who watches, but who's judging that particular LLM? That's my question. Anyways, but it's a good strategy, works reasonably if you're using, say, a specific fine-tuned model for your domain-specific AI bot, AI system. You can use a higher power model, which understands the world, understands like a jack of multiple trades that they are, to use that to evaluate whether this answer looks reasonably well, coherent, relevant, faithful, and all the metrics that we discussed. Right? That's called LLM as a judge. It's an evolving evaluation technique. We have used it at ThoughtWorks in several engagements. It's expensive, of course. Why? Because you're using burning more tokens to evaluate and test your AI system. But so it is effective, but expensive. But this definitely works. Yeah. By the way, this is how like a production grade rack system looks like. Count the number of models here. Count the number of models. Yeah, you get the point. But there are so many things that happen in a production grade simple rack based system. I'm not even talking about agentic systems. I'm talking about rack based systems just as yet, right? So that's the number of models that it takes, and that's the complexity, and that's why I started off with a mental model of how do you perceive complexity as a dev, as a QA, as anybody else on the team, right? That understanding that complexity is really important to really wrap your head around such systems, design an effective testing strategy, define an effective evals strategy so that you're doing the right thing, at least directionally. Remember the vector theory of change, your goal of building trustworthy, reliable AI. Okay. But are the first principles lost? Like what we have been doing as a quality analyst or software testing, the way we have done it, is it all gone? Is it all like we should forget that? No, we should not. Excellent. We should not. Right? There has to be coexistence of these two worlds. Right? We cannot live without the other. So you have to have both of them in tandem working together. You remember that full part of production, we had everything in there, right? Like we had testing before commit, testing before deployment, testing after deployment, and observing, right? So both the worlds have to coexist while building very good success systems. This is how full stack testing looks like. Agree with me, right? We have to think about usability, performance. We have to think about security, data quality. We have to think about fairness, whether the system is unbiased. We have to think about regulation, compliance. You know, I have not even added a lot of other realities that are important for a system, but you get the point, right? That this is like an evolving view of how, when we think about software tech quality, it's expanding like at a very fast pace, like Big Bang. Like it's expanding in both directions, in all directions. And if you don't think about these things, then there is something directionally wrong in your testing strategy. This is how, in my opinion, that product teams need to think about, like, think of them like hats, right? Product teams need to be data strategists. Why? Because your AI is as good as the data, right? The data quality that you feed into your rack system defines how good the response is going to be, right? So you have to think about data strategy, data quality, that is right there in the spoke. You have to think about accessibility, right? Whether your system is accessible or not. Not everybody can use language to interact. So should you invest in multimodal AI systems, right, which can hear voice? And not everybody understands English. We are in India. There are 20, I don't know how many Indic languages. Maybe then you should support, right? Indic languages, speech to text, and then the process, right? We need to be, all of us need to be user experience advocates, right? I don't think only the UX person on the team has that responsibility. Everyone has to have that responsibility. Policy guardians, I think, again, take it back to the model. If you're not thinking about policy, I'm sure you will falter on maybe these two or the transparency bit, right? Performance tuning, the responsible tech. I think that responsible tech encapsulates a lot of things: fairness, bias, and transparency, explainability, and so on and so forth. We need to be thinking about all of these aspects when we are designing our testing strategies for the new age systems that we are building or we are going to build. But relax, everything is out of control anyway. Thank you so much.